Hey everyone, just wanted to real quickly walk through what we did as a class for our class data, and also give you guys a chance to kind of understand the directions for this last assignment. So here we have the weights of the cans that were used, and then the lengths of the gaps spanned by those bridges. So what I want to show you is how to make a graph in Google Sheets here. If you click and drag over your data like so, and then press Insert and then Chart. It looks like it's quite large. Make this a little bit smaller. I have everything enlarged here, so it's kind of hard to see. I'm going to zoom out to maybe 150 and see if we can see it. All right, so here we get this beautiful graph. And we can see that as you're looking at this graph, as the size of the can increases in ounces, we can see that the lengths, probably the average length of the gap is slowly decreasing. And so there's this thing that we can do in mathematics and statistics. It's called a linear least squares regression line, or a line of best fit. And you can do this if you go to series, trend line, and then let's see, and then the label, we just use an equation. So this equation right here has a meaning, okay? So what it's saying is, so the y-axis here is our vertical axis, represents the length of the bridges. So each data point represents somebody's bridge and the can that they used, right? So each dot represents that. So like this person right here looks like their can weighed about 8 ounces and the length of their bridge was over 50, so pretty close, right? So that's what that data point means. So this is an equation, a linear equation. And it is, I'm going to go ahead and write it out for you. It's, if we're talking about y and x, which some of you, maybe it's been a while since you've seen this, but you should hopefully have seen it once. Let me get my paper off here. But we have an equation, a linear equation, and it is y equals negative 2.81 x plus 65. Now each of these numbers, negative 2.81 and 65, has a meaning in terms of the problem. So here is our trend line. This is our trend line. That it kind of gives us an idea of where the data is headed across the different weights of the cans. Like, where is the length of the bridge headed? And there's a general downward trend, and you shouldn't be surprised by that, because as can size goes up, it's harder to hold, right? So you shouldn't be too surprised by that. What I'm asking you to do, let's run through this assignment real quick, and there's a couple questions about this that I would like to cover. So the first one, we'll get to those questions in just a second. The first one, describe a strategy you chose for the construction of your final bridge, writing out a list of directions. So I want you to make it look like you're teaching someone how to assemble the bridge the way that you assembled it. So one sentence is probably not going to cut it. Make sure you go into detail there. Describe in detail what happened during your bridge test. Where did it break? How did your bridge break? Multiple sentences responding there. After looking at other designs from the class, whose design was your favorite and why? And right here is a scatter plot. Now this has got, I think, is missing a data point or something, so the number's a little different, but that's okay. Part A, why is it important for an engineer? I'll let you write what you think those are, and I think you can do C and D. E and F are the tricky ones. What does the 65 represent in real life, and what does the negative 2.77 represent in real life? Okay, so our numbers are a little different, but they're pretty close. If you remember from algebra, this number represents the slope or the rate of change. And if you remember from algebra, that's the change in y over the change in x. But y, in terms of our problem, is the change in the length in inches over the change in weight in ounces, right? So this number is the y-intercept. So what do these mean in real life? What am I looking for these answers? Okay, what the 65 means, let's look at our graph again. This 65 means that if we randomly selected someone from the class, we would expect them to build a bridge that is basically, if the can is 0 ounces, we would expect their bridge to be about 65 inches long. So this is at x equals 0. When x equals 0, the graph is at 65. So if a person constructed a bridge with no weight, we would expect their bridge to be about 65 inches long. No weight is the key. So in that response, you need to make sure you have no can and the length is 65. Okay, what does this number mean? Negative 2.77. In this case, it's negative 2.81. What does it mean? This is our slope. This is our rate of change. Filming a video. Hold on. Just a sec. We're cooking dinner simultaneously. Busy house over here. Anyways, this is the rate of change. So what that really means, how do I write negative 2.81 as a fraction? It really means negative 2.81 inches over 1 ounce. It really means that if I go over on my graph, if I increase, based on the line, for every 1 ounce increase, I can expect the length of my bridge to drop 2.81 inches, or to get 2.81 inches smaller. So if I increase the size of my can 1 ounce, on average, I can expect my bridges to get 2.81 inches shorter. That's what that number means in real life. It has physical meaning, okay, to the problem based on the data we collected. Now, these numbers are just based off of the data that we collected. Okay, why did I show you that? That's math, it's awful, we're in engineering. The reason I showed you that is because it's oftentimes you're in math, right? And you're trying to look out to see something relevant. When really the best way to find the relevance of mathematics is not when you're in math class, but really when you're somewhere else and you need math to help you. And that's what we've done here. We've used math to help us make predictions. So the last question says, I'll let you do this on your own. The last question says, using your class data, predict how long a bridge is likely to be if it's required to hold a can that is 9 inches or 9 ounces. Okay, let's not do 9. Let's not do 9. You're going to do 9 for your assignment, and I'm going to grade that. Let's do one that's not on here. Let's say a 6-ounce can. 6-ounce can is right here. We would expect a 6-ounce can to be a bridge that's holding a 6-ounce can to be about, let's say like 45, some high 40s, or high to mid 40s, 47 inches long. So let's do the math. So again, I'm getting that from a data point. If I'm at 6 ounces and I come up and hit my trend line, this trend line is what we would predict, right? It looks like it's at about maybe 47, 48. So let's do the math and let's see if that is true. All right, so for a can that is 6 ounces, remember X is ounces, so I'm going to plug in here, negative 2.81 times 6 plus 65. Let's do the math. Get my calculator out. Right. Right, that's 16, negative 16.86. Again, I don't, let's see, negative times positive is a negative. 16.86 plus 65. That was pretty close. 48.14 inches. So that's why these lines are useful. They allow us to make predictions. And so, engineers do the same thing. If they're collecting data, they're trying to keep people safe, right? If they're collecting data on something, they can use that data to know where things are going to fail and make sure that the bridge or whatever they're building is never put under the in a situation where it might break. So that's what engineers do, making sure people are safe, collecting data, and knowing when things are going to break. That's all for me today, folks. Hope you liked the video, and feel free to get this assignment to me as soon as you can. The last question is just feedback for me about the project. So have a good day, everybody.